So we have Viktor to actually host the second session of the Crossplane book. We've been super lucky that he's joining. Now he's literally back from KCD Istanbul like 5 minutes ago, and he will help us read this lovely book.
Yeah.
So let me some news. So we continue doing the Thursday. They're doing machine learning on Kubernetes. We have the coupon code Kubernetes. I don't know how to pronounce it. Like it's 10 years of
Kubernetes,
Kubernetes.
Kubernetes.
Bash
I don't know.
Party is there. The link is there. I don't know if you want to open it or not, but the it's June, that week of June 2nd to June 7th. Around the world there will be bash parties. People are hosting it in different cities, so you can join live. I'm hosting one here in North Carolina, Raleigh-Durham. I was able to find a venue, a sponsor. I'm trying to look for a sponsor for a cake or food. So you can sign up if you live here in Raleigh, North Carolina, and then that's June 5th. I'm doing it. And it'll be 1 hour here, and I have some cool tricks to show. I'm going to show Kubernetes 1.0 running. So we were able to run Kubernetes 1.0. We were able to find the binaries, find an old version of Ubuntu, old version of Docker. So we're going to show that. We have a website. I'm going to show it maybe later, but that's going to happen. And yeah, and then the next thing is I was able to find another person like Viktor willing to come here on Fridays and join us to talk about their book that they wrote. So Sergio Mendez, he's from Guatemala. He wrote a book on edge computing with Kubernetes. He's a professor. I was a professor in a university, and he does a lot of like classes and courses and work around edge and machine learning. So he's going to join us with his book on edge Kubernetes, like running things in Raspberry Pis, TinyGo, how to do machine learning on the edge, small boxes, and he has a book. So I think he's going to do like 4 sessions after we're done with Crossplane. So wanted to give that heads up on the new book. And I think that's it. Welcome everyone. We have 17 people. Oh,
That's brilliant. Yeah. I'm really happy. I got to meet Sergio in an Amsterdam meetup once. It was so nice to talk to him. I'm really pleased that he's joining. Feel free to drop news, guys, into the doc so we can read afterwards. And Viktor, the stage is yours.
yeah. Go
Okay.
ahead.
Okay. Let me see. Just a second. Okay. No, you need to stop sharing your screen, I think, and then I can
sharing.
share mine.
When I
Whomever
do it,
it is.
I never find the unshare button. Then it's for me.
Okay. Let me see. Share screen. There we go. You should see my screen now, right?
Yeah, let's see it.
Yes.
Okay. So in the previous one last week, we went through basically the end result, like Crossplane doing zillion things at the same time. Now the next chapter essentially goes back to the very beginning, right? The most basic things in Crossplane, which is using managed resources, right? Managed resources in Crossplane is, I mean, it's just a term. Basically, it's usually creating custom resources that are mapping something somewhere, like EC2 instances in AWS or whatever you want to create, right? And yeah, just as last time, please continue stopping me and asking questions. That was so awesome. I don't like speaking long time by myself.
We discussed this on LinkedIn. Like, will you be able to finish if we keep asking questions? Like, this book might take too long.
I don't know, but I feel that that's the awesome part. I mean, it's not mandatory, right? Anyways, I just start, as I said before, every chapter has a setup script and destroy script. This is I'm just going to run the script that will set up everything I need for this chapter, doing it right now. In this case, almost nothing is set up because this chapter, among other things, shows people how to install Crossplane. So essentially, what I'm going to do is create
So
a
this
kind
one is
cluster.
which one? This one is providers and managed resources chapter.
Yes,
chapter
that's
2?
the one. Managed resources. I don't remember the name of the chapter, but managed resources something. Providers and managed resources. Yes.
Yeah, managed resources, providers and managed resources. Like to learn that.
Exactly. Exactly. So I have my kind cluster now in production. For real, you wouldn't run Crossplane in a kind cluster, right? But for practicing and demos, it's going to be good enough. And what I'm going to do first is install Crossplane, right? Probably not much to say about it. It's just Helm install. There are no even special values or anything like that. Just Helm install.
Yeah,
It will
about
install it.
kind. There's people running kind in production. It used to be used a lot in CI/CD pipelines, like Kubernetes kind on Kubernetes. But these days, I see more like vCluster than using kind.
Yeah, I mean, I somehow associate usefulness of kind to having Kubernetes cluster on my machine,
Yeah.
like laptop. And if I do often need, let's call it ephemeral Kubernetes clusters, temporary Kubernetes clusters, maybe even permanent Kubernetes clusters, so that I have separation between different tenants. But vCluster kills that domain.
Yeah.
Strongly recommend that over kind if you're
Me
talking
too.
about
But
something more serious.
remember back in the days. Like yeah, we had kind, but vCluster is like the top choice now.
Exactly. So Crossplane is up and running. It doesn't do anything by itself, right? To be able to do anything in Crossplane, you need a provider, right, or multiple providers. In this example, I'm going to go through. I'm going to use AWS again, and I'm going to install EC2 provider, right? Now, there are two options when you install providers in Crossplane. One is to install all of the whole AWS, for example, right? That's probably an overkill for majority of people. Don't do that. Or you can pick and choose and say, I want AWS EC2 API. Now, this is not literally only EC2. Those are all the endpoints, probably like 50 to 100 endpoints that are related to EC2s, like, subnets, VPCs, stuff like that.
And the problem also installing all of them is the number of CRDs, right, Victor? Like having too many CRDs is problematic. It used to be very problematic in terms of performance. The Kube API, I think we talked that last Friday, but in this case, you're picking like a subset of CRDs that you're interested in.
Exactly. That's the goal. Let me apply it, and then I will show you the CRDs. Kubectl get CRDs. Now there's probably not going to be much. Let me make this smaller so
EC2 has a bunch. Let me see.
Now there is not much because it takes a while until it flows them all into etcd and so on and so forth. So I'll get back to CRDs in a second, right? What you can see here, if you do kubectl get pkg rev, that's all the packages managed by Crossplane and all the revisions of those packages. You should see that. There we go. It is right now installing EC2, and there is, let's call it a root provider, right? Some very basic things that the absolutely necessity that is always installed when you install any of
family, right? It's called family.
Exactly.
If people hear family, this is what I refer to. Like it's a common base. I don't know what to call it. Like what you said.
I'm not even sure how we call it, so I'm going to call it, I don't know, root provider or something like that.
That should be root. Yeah.
Exactly. And if I go back now to, let's see whether it's finished. Yeah, you can see here by the state, right? Now EC2 is active, and the root one, or whatever the name is, family provider, is active as well. And if I go and execute get CRDs again, now you can see that I got, let me see actually, vc-shell, how many is that? 119, right?
Yep.
Not so, probably like 110 were 9 probably were there from kind itself, and Crossplane and 110 approximately were installed with EC2.
Yeah,
right?
You see VPC there. You see VPN gateways. I'm guessing instances also.
Yeah, there should be. Now I forgot whether it's called instance, right? Probably it's instance. Yeah, instances. Here we go.
Yeah,
There we go.
It's for a VM, right? Yeah.
Exactly. And the only thing before I proceed, what I'm going to do is I'm not going to show you for obvious reasons, especially since it's recorded, but I'm going to create a secret with my AWS creds so that Crossplane knows how to communicate with my AWS account. And the second thing I need, I think that this is the last one, is the config file, right? This is basically a config that says, hey, whenever you use anything AWS related, use this secret that I just created, AWS creds. That's where the credentials are. Go for it. You should be able now to talk to AWS. Actually, it won't be able yet, but if I apply it, now it should be able to talk to AWS, right?
So Victor, one thing I want to share is this week in AWS, some of the essays we were investigating how to make this even simpler. And one tool that we found, I put it in the chat, is called AWS-Vault. And if you run that tool, you run AWS Vault --EC2 server, it runs kind of like the metadata server in your computer. It gives you a shell, and then any container, Finch, Docker kind, then Crossplane, anything that needs a AWS credentials, it calls the metadata API. It gets authenticated to whatever profile you want or a role in your computer. So there's no need for hard-coded. So I think I'm going to send you the details. We're planning to do a blog post in AWS on this because it's super annoying to do the hard-coded credentials, at least for me.
Yeah, I use the AWS Vault.
Oh, you use it?
It's a great. Yes, I use it both for work and personal, and it's great.
I'll reach out for feedback. I'm looking for customers that use it in AWS. Sorry for the vendor pitch.
I've been using external secrets operator to sync secrets from AWS Secrets Manager into Kubernetes secrets.
Oh yeah, that's the preferred choice. I'm talking about your laptop only. Your laptop.
Okay.
Yeah, for kind or Docker run.
I guess it also depends on whether it's only AWS or you have other stuff. An alternative that I can really recommend is Stellar. This is the one I have in this project. Yeah.
What is Stellar?
So Stellar basically, so what I executed before I started this session was this. Basically, Stellar SH, there are different Stellar commands, but basically SH would convert. Exactly.
Nice.
Basically, every project I have, almost every project has Stellar SH there. It's stored in Git. Nobody can do anything with it because it gets data from my secret manager.
Yeah. Okay, cool. Yeah, this is for environment variables. The one I'm saying that's more to get them into kind.
Okay. That no. Yes.
Yeah. This is cool. I didn't know about Stellar. We should write it down in the notes if somebody wants to add it.
It's one of the CNCF projects, man. One of the 200. Nobody can know them all.
I'm a CNCF ambassador. I don't know them all.
Nobody does.
Quick question. On the provider config, is that where we could specify different partitions such as AWS GovCloud? Is that possible and supported by the Crossplane AWS provider?
Yeah.
You mean this one? Yeah.
Yes. That's where we would specify GovCloud?
Yeah, exactly. Basically, you would have as many configs as you have providers, right? So this config is only for AWS. If you would be using, I don't know, something else that requires authentication, you would have a separate config file.
Or cross accounts or assume role. It has there's a documentation for all the type of combination of authentication in a specific provider.
Thank you.
Cool. Okay, so let me show you the meat of this in this chapter, right? This is essentially a file, the manifest. So this is no composition, nothing fancy, right? Very, very basic. And I will use this to create AWS instance. Most of the resources here, these have a for provider section that if you go, actually, let me open that. No, not that. not that. Where am I here? If you go to marketplace, think of this marketplace as being equivalent to Docker Hub for Crossplane something. And if you search for EC2, you would see the, come on, where are we? There. Those are all the documentation of all those CRDs that were installed when I installed the EC2 provider. And then you can go to any of them and see the exact schema, right? I don't know, spec has provider, most of them do, and then those are the fields for whichever host, right? I don't even know what is host in AWS, but for all the fields that you can use, the complete schema for that something, right? And in this case, I'm creating EC2 instance based on this AMI, that region, instance types, and so on and so forth. Now, this part is important, right? This is the reference to the subnet resource, assuming that you use a subnet with that instance. So I'm saying here, okay, but whatever you need to gather from the subnet, whichever information you need to inject into the instance itself, you will find it in subnet called myVM. And that subnet is somewhere. Here we go, right? That's another resource in that manifest. Subnet myVM has another same region, some availability zone, and so on and so forth, right? So basically, I'm here specifying the subnet, the VPC, the instance itself, and the state of the instance. I want to make sure that it is always running, right? In this specific example, I could have skipped this one.
Yeah, that's interesting. I never play with instance state.
Because basically, without this one, because basically the instance itself, API endpoint in AWS doesn't have the state exposed, right? So if I create an instance, and let's say that I destroy it by accident, Crossplane would not recreate it, because from Crossplane perspective, sorry, if I stop the instance, Crossplane would not start it again, because, hey, you're matching the requirements, the specification. And this is basically just telling that, hey, instance should always be in the state running forever and ever.
Yeah, and by reference, right? Everything by reference. So these are Kubernetes reference, like the metadata name, right? That you put in those ref.
Yeah, it's always basically there are different types of references. Most of the time you would reference. So when you work like this, and let me give you a warning. You will most likely never work like this with Crossplane.
I know. And composition is like
you would never work with pods directly in Kubernetes, right?
Yeah.
But you need to understand them.
Yeah.
Anyways, there are different types to reference resources. Now I'm explicitly referencing and saying, hey, this instance state is referencing instance with the name myVM, right? Later on in the next chapters, I will show you a better way to do it, but for now, this should do, right? And yeah, interrupt me at any moment.
No,
what else?
This is super useful. I thought I knew Kubernetes Crossplane, but I'm learning a lot.
Hey, by the way, you said that you did not know about instance state. I did not know until I started writing this book.
Yeah,
I wrote it without, and I wanted in a book to demonstrate people what happens if you stop an instance. And then Crossplane will recreate it. And then, fuck, do we have a bug? We must have a bug. It's not starting the stopped instance. It took me a while to figure it out.
Yeah,
but anyway,
that was a really fun comment there in the book.
Yeah, my personal experience is mostly creating EKS clusters, so I don't touch the VMs. I just like create Carpenter or managed node groups, so that the VMs should always be running.
We have Viktor's hand up.
Okay.
I'm most certainly butchering your name. I'm sorry.
No, it's okay. I know when you're calling, but I appreciate the understanding or the intent. Quick question regarding the API extension from Crossplane. How does it handle cloud providers such as AWS in terms of the amount of requests that you can perform from the Crossplane side to monitor whether the state is maintained? And do we have any issues of 429s or thrallnecks? Do you make a derivative of the request in terms of amount, and you extend that to all other resources that are consuming that endpoint? How up to date is that endpoint?
How up to date? It depends really on the. If the question how quickly the new endpoints are added to the provider.
In a sense, yes, but because we, as you said here for the instance, right, the instant state stop versus unstop.
Yeah.
How you utilize AWS API endpoints to query that, and like most of the subscription model of Kubernetes, you continuously monitor the annotated versus denotative state. How does Crossplane handle, some resources, for example, like ECS service have pretty have a way to limit requests, and they don't handle a lot of requests. When you want to integrate, for example, Prometheus with ECS services, in the past they had you weren't able to get a lot of metrics endpoints and service endpoints and so forth because of the inherently low metrics bandwidth. So how does, considering we have a resource orchestration solution here for via the provider for Crossplane, how does it handle not just AWS but all cloud providers, all cloud cloud resource providers?
The simplified version is that it periodically sends requests to all to the endpoints related to specific resources, and you can fine tune the frequency of that. I'm not sure, to be honest, now by default what is the frequency.
Yeah, I can answer. It's 1 minute. So it will go back to the cloud provider to see if you're continuing having the state, right? Continuously. And if you do that a lot, you get rate limited. So the same way, if you run Terraform in a loop, in a cron job, right? Against something. So I posted the links to the monitoring. When people run Crossplane production, they use this guide of monitoring Crossplane, where you have the metrics, and the way is you have to tune it back of like saying, instead of going 1 minute, you say go every hour or every 2 hours, right? And then you go slower to the AWS API, and depends on the AWS API that you're hitting, or Azure or whatever. I can talk about AWS. You can work with us if you're using a lot of consumption, and then we can work out if it's fair and we can increase the limit, or we can just help with you saying guidance of like, this is how you tune Crossplane to not go that fast. And that should be okay to make it like less fast. Yeah.
That would be great, because I'm obviously thinking about the overrun question. Sorry, Francisco, but overrun question of how does it scale?
Yeah, it scales.
You have a lot of compositions here and a lot of XRDs that developers, you want to extend this to the platform for developers. And let's just say you have a database, right? Like one of the examples where you extend the database and the Postgres and everything is simplified and abstracted, and that is used by hundreds of teams and each of those. So how does that look from the platform? Because it would be the platform engineers or the platform team's responsibility to make sure that they extend it to developers, and they handle how the cloud provider of choice responds accordingly, right?
Yep.
In a sense.
Yep. So yeah, it handles, and it has tuning, and the platform team will adjust the YAML file of the provider to go slower, right? If you have 1 million RDS databases being created in your AWS, in your single AWS account, then you can tune it in a way that you can scale. And there's people, I can talk about AWS, not the other clouds, but we have customers, thousands and thousands and thousands of. You can go to the Crossplane Slack. I think go to the Crossplane Slack, and you will see other people saying how many thousands of resources they have in the cloud and how do they deal with it and how it scales.
But not directly related with that question also, Crossplane actually doesn't make sense, to be honest, on small scale. Kind of,
Yeah.
you're not going to create a Kubernetes cluster to manage one Kubernetes cluster, kind of. So the goal is really to work on very large scale.
Yeah, dozens of clusters, dozens of RDSs, right? Yep.
Go big or don't do Crossplane.
Yep.
Exactly. Okay, it can be medium as well. Don't do very small. Okay, this is cool. So let me apply this, that same YAML that I showed you with instance, VPC, subnet, what's or not. And what you will see if I apply it is if I say get managed resources, and managed resources is managed is like an alias. Basically, it returns all the resources managed by Crossplane. Think of it like Kubernetes all, right? And you can see now that, for example, instance was not even synced. So actually, two important columns here is ready and synced. Synced means that Crossplane has all the information it needs to start working on that something. And ready means that it's ready, it's available, it's created, it's running, right? Now, you will see often synced false. And what that means is that this instance, for example, most likely, this instance actually was referencing subnet, and subnet references VPC. And at that time, when I executed this get managed, VPC was not yet created, right? So Crossplane could not proceed at that moment with subnet, right? So and this is kind of very much Kubernetes-like and very different from other tools, right? It's expected to fail until it doesn't, right? And if I execute get managed again, now you will see that, yeah, instance is both synchronized and ready. But instance state, for example, this is probably that VM is now probably initializing or starting the OS or whatever it's doing. So it is not yet running, but instance itself, the state of it is as expected, right? I see a hand, Francisco. So
yeah, my question is about. I'm not sure if this is the only way to monitor how is created the resource. Is just to execute continually kubectl get manage, or is there any other way to monitor how the resource is created?
So there are, later on when we get to compositions, there is Crossplane command. You can do something like this and say, hey, give me all the resources related to that composition. I think I showed it last time, but later on we'll get to composition and show you. But outside of that, that's Crossplane itself, right? And without me entering into outbound commercial and stuff like that, the short answer is however you would monitor whatever you're doing in Kubernetes today, right? If you are using Lens or you're using Prometheus or Grafana, right? It's all Kubernetes resources. Whatever you're doing to monitor today, that should work with Crossplane as well.
Okay, perfect. Thanks.
Nice. Okay, so what did we say? Get managed now should be fully operational. There we go. The state now, the instance state that is set to running is true, meaning that my VM should be up and running. And if I open it, let me open it in a browser quickly. Let me put it on a screen, right? Oh, MFA, amazing and annoying at the same time. Let me see my code. Sorry for that.
While you go in there, another thing about that tool that I mentioned, AWS Vault, I just found about it this week. You can run AWS Vault with a command to give you a URL, a login URL to the console, and it will open. Then you can open the console and go right in the console without logging in the browser.
Oh, nice. Sorry, I had to. As I said, I just arrived from Istanbul, so my machine restarted and I had to start the last password. Here we go. Okay, now it should work. Let's see, 06. Cool.
Oh, LastPass, and I have another comment about LastPass. There's an episode. I'll put the link. There's an episode, a podcast. I listened to the Chip It podcast from Changelog. There was an engineer, the director of engineering platform from LastPass was there, and he was telling how they move from using Kubernetes for developers using Kubernetes in local machine like Kind and Docker to use Nix OS. And he tells like the story on how they move everyone to use Nix. Is it Nix? Nix OS.
Nix is amazing, man.
And so that's interesting story there.
Yeah, but I moved completely to Nix. That's the best thing that happened to me in a while. Where was I? Yeah, so the VM is running now. Instance type is T2 Nano, right? Because that's what I specified there. And let's say that if I would like to change something, now this follows the typical Kubernetes stuff, right? Let's say that I have this manifest, now VM bigger, that changes T2 Nano to T2 Micro. I'm going cheap on you guys. And if I just apply it, then you can see that everything stays the same except that the instance changed. And eventually, I think that once the next, there we go. No matching instances. Now I'm worried what happened.
There you go.
Yeah, actually it's stopping it exactly. And it will create a new one, right? Now, what will happen? Now, this greatly depends on the provider, right? In some cases, when you update something in Crossplane, some resource, it will update that resource wherever you're running it in AWS. Sometimes it will destroy it and create a new one. That depends on what the API brings. I'm guessing, and Carlos, you probably know more, you cannot increase the size of VM without creating a new one or something like that, right?
Yeah, you cannot. You can change volumes and things like that, like storage.
Yeah,
but not
exactly.
like the number of CPUs and GPUs you get, the memory is fixed. Yeah,
exactly. So this will be shut down, and then the new one will be created. And
does it wait? That's interesting. That's interesting. Does it wait for one to go away to create the second one? Doesn't create.
There we go.
Oh, interesting. Okay.
Done. Exactly. Because it assumes that there is one, right? You didn't say I want 3 or 5 or whatever you want, right? And similarly,
but
if
right, the ID that you get back, that instance has the same name, but it's a different ID.
So that's so if I do get the instance, let's say this one, right? And output, you will see that what Crossplane essentially uses etcd for the state. And let me just find it, external name, right? Yep. So it injects this annotation to the resource with external name being whatever it is, right? This is how it tracks something. In case of some resources, the external name is what you specified. In case of others, correct me, Carlos, instance auto-generates ID, so it's not the ID that you said. You can specify the tag, not the name, the ID. So it uses this annotation to track what something is. And probably when it created a new one, then it changed the value of that annotation.
So this is a magic that external name annotation. I call it the magic annotation because a lot of people don't know the magic. This magic annotation is important because you can adopt existing resources. So for example, if you have a VM that you already created by hand with the mouse, and you want to now start managing from Crossplane, then you can create a managed resource, but you have to put this annotation with the specific instance type or the ID or the RDS ID to tell Crossplane, hey, do not create me a new one, just attach and start reconciling that one. And the way you find it is with this ID, the type, and the account. And that way you can start like attaching to things that you created with the console, maybe with Terraform, something else. And I call it like the magic annotation. I don't know. That's the name I give it.
Yeah. And it's not necessarily always. Yeah, I might be wrong, but for example, EKS, I believe, is the ID is the name. So if this would have been EKS,
it happens to match. There's a
exactly.
Yeah, cluster name is a unique thing, but it will be located in the external name. Will have the cluster name that you see in the console.
Exactly. And That's it about managed resources. The only thing left I have in the book, okay, kind of, if you, by the way, if I go here and say, let's say instance state stop.
Oh, like a sneaky SRE trying to mess around with the run thing.
Exactly. Exactly. Somebody.
I call it the sneaky SRE.
Exactly. Eventually, and this depends on those reconciliation loops. Whenever the next reconciliation loop kicks in, it will see that the instance state that I specify should be running is not the same as the actual state, and it will start it again, right?
Yeah, this is why some people ask me if Crossplane does GitOps, and I'm like, well, it has a property of GitOps, right? The reconciliation and the drift detection. So some people don't know the specifics and things like that, but yeah, it's like GitOps. If you change something, it will put it back to the desired state.
Yeah, so I see GitOps maybe slightly differently, right? Kind of than many people. Let's say I'm going to ignore Crossplane right now. GitOps really is synchronizing the desired state in Git with the state of your Kubernetes resources. That's not necessarily the actual state, right? With etcd, exactly. And then if you synchronize ingress, it's not GitOps that will create a load balancer. It's ingress itself that takes it over from there on, right? The actual state is usually not, often not Kubernetes itself.
Yeah.
But yes, you use Argo Seeder Flux from Git to your cluster, and then Crossplane from your cluster to wherever you're going, right?
Yeah, no different than the storage CSI driver, right? Or
exactly.
The ingress load balancer for your cloud provider that is creating volumes and is creating load balancers.
Exactly.
Hey, Victor, I have seen for AWS, right? There are many providers. So what's the recommendation for customers? Which one should we pick?
There are, let's say, two types of providers as far as I know. There is, I'm not sure about the names. There's the first one that started is probably called community provider or something like that.
Community contrib. Are you sure you used to call it?
Exactly. And there is Abject provider, which is the one I use. The outbound folks or maintainers of Crossplane that are working outbound are focused on the latter, on the Abject provider. That one is, I'm going to say, almost complete, just to leave a room for somebody to say there is one resource in AWS missing, right? But if not 100%, then 99.5% complete, right? The community, I haven't checked it in a while, but last time I checked, I think it had around 200 something.
300, yeah, 300 something. Yeah, the outbound, I need to start calling it outbound because outbound donated the provider to the CNCF Crossplane repository. So now it's a Crossplane object one. So it's not longer in the outbound, but it's on the Crossplane.
It's just that
that's 1,000, I think, right? Yeah.
There are. It's still the API is still called outbound.io for two reasons. First, maybe you can say because we were too lazy to change them more, but more importantly for compatibility, right? Otherwise, it would break everybody's clusters. But yeah, everything I'm showing here is CNCF, right? The only thing that is not CNCF that I showed, that's the marketplace, right? Which is Docker Hub like for providers.
And also, Victor, when you were selecting providers, right, there is a version 1.4 or something, right? So when you are selecting different providers, like one for AWS, Kubernetes, something else, how do you make sure they're all compatible? Do you need to worry about that?
So I haven't seen issues. I cannot guarantee that they aren't, because you can be using AWS EC2 provider, I don't know, 1.00, and then RDS provider 1.17. It should work because they're really separate. There is that central main one that is not really doing much. I don't think you should have issues.
Yeah. Within
If
within
you-
the within the AWS provider object, all of them get released at the same time. So 1.01, like the RDS, so you should upgrade at the same time. If you're talking about a different provider like the Kubernetes or Helm or the Jira ticket or the Argo one compatible with the AWS one, they're totally different APIs. So there's nothing to worry.
Okay, with the
Yeah.
cloud provider, you better choose the same version, right?
I'm saying you don't have to.
Okay.
It's not going to explode, but in most cases, kind of, if you're going to update EC2, you're probably going to update RDS as well, right?
Yeah. Yeah, it's for me, like I use one Helm chart to install like all the family providers, and I put the version in one place, and then the Helm chart just creates all of them in the same version for consistency.
And also, we are following the semantic versioning like in Kubernetes itself, right? So you should be worried if right now AWS provider is on 1 something.
Yep.
You might have to put special attention if you ever reach version 2, right? But all the minor versions should be backwards compatible. So you shouldn't.
1.4 is the last one. I put the link there.
There we go. My book is outdated.
And can you, Victor, can you also do something like a dry run to see what apply does?
He wants Terraform plan, Victor.
Yeah. Is there something?
Well,
like
you have opinions for that?
Yeah, I have 2 opinions. First, I have news and then opinions. News is that many are asking for it, and so many that we gave up on explaining why that's not necessarily a good idea. And we are working on it. But I say
Really? Okay.
Yeah, without promising, I cannot give you any date, even the approximation.
Crossplane plan coming soon.
What was the explanation for that? It was not a good plan, good idea.
It's still not a good idea.
So because so let's forget for a Crossplane for a second, right?
Yeah.
Let's say that you run Terraform plan for Kubernetes resources, like deployment, right? Deployment is going to create a replica set. Replica set is going to create pods, and then how do you execute equivalent of Terraform plan that will tell you where the pod will run before it runs, right? A lot of conceptually they're very different. If I compare it with Terraform, and I'm not trying, just using Terraform here as example, right? Terraform, everything is decided and executed by the CLI, right? All the decisions are made there. Kubernetes is different. When you send something to Kubernetes API, you're just getting acknowledgement, kind of, I understood what you want. It will happen eventually, right? Eventually your pods will be somewhere, but you don't know where that will be at the time you get response, right? Scheduler will figure it out eventually. Maybe even will not be able to run your pods because it will have to create a new node, right? To increase the capacity and so on and so forth. So the complexity of having a plan is very different because scheduler is doing work constantly, right? It's not one shot.
Yeah.
But it's a most commonly quoted reason for people not to switch to Crossplane. It's kind of, oh, we love this. This is amazing. But we are currently running Terraform and we cannot live without a plan. So we're building it.
The same thing. I can give a different example that I get asked all the time. Like when people are starting with Argo CD and they're used to now that you change something in the YAML and you check it into Git, how do you make sure, how can like the same Satish has like, how can I plan or see a dry run of like what Argo CD is going to do when I merge the PR? Right? The same concept. It's like you have to merge, run it in a ephemeral environment or get the diff of the YAML eventually, but once it goes, it goes.
Yeah, and even that diff of the YAML, right? There is dry run flag in Kubernetes, but it gives you the differences in manifests. That's not the same as, oh, I'm going to tell you what will happen with your pod, right?
Yeah, it would give you like the difference, the version of the Helm chart is different. It doesn't tell you like, or even the deployment doesn't give you what's different, the replica set or the pod.
And yeah, you change the image, right? But that's not the same.
Yeah. Good question, Satish.
Yeah, keep them coming. Keep them coming. So this is the end of first chapter. Again, I'm going, not telling you everything and not reading every paragraph and all that stuff. Actually, not reading anything. Anyways, jumping to the next one. Next chapter is about compositions, right? Which is what I said before. You're most likely never going to work directly with managed resources like what I did now, but you will be creating compositions, which are abstractions that give meaning to a group of resources. And first thing I'm going to do, I did not comment on it, but I destroyed everything I did in so far. So I'm starting from scratch. Every chapter does. This is okay. So I'm creating a client cluster again. This time I'm not walking anybody through installation of Crossplane and providers. The setup script will do it. So this will take a couple of minutes.
So
great time for questions.
Every chapter creates a kind cluster from scratch?
Every chapter.
Oh, nice. Okay.
So at the end of every chapter, there is destroy something sh command, because I did not want people to, since Crossplane heavily uses cloud and what's not to, I didn't want them to keep it. Oh, I'm finished the chapter. I'm going to continue tomorrow. And then send tweet to Viktor that he's generating unnecessary cost.
That's true. That's true, because you're creating cloud resources. That's true. Yeah.
Yeah, and not even that, kind of like, why run it overnight if you're not using it? Whatever, even if it's local. Okay, so that's the setup. Now here's the definition of so composition is a way. If you're using Terraform modules, think of compositions as being somehow similar, yet not the same as creating Terraform modules, right? And in this case, there are actually two parts of creating compositions. There is definition and one or more compositions themselves. Definition is essentially creating a custom CRD in Kubernetes. And in this specific case, I'm going to create two CRDs. One will be called SQL, and another one will be called SQL claim. The difference between those two is that the first one is cluster level, right? And the second one is namespace level. So if you want to create, in this case, databases, SQLs, in namespaces, you would create a custom resource called SQL claim, right? And this is almost the same YAML as you would use to create CRDs in Kubernetes alone, right? There are very few modifications. There is always at least one version. That CRD will be called V1 Alpha 1. Only one, if you have multiple versions, only one can have served true. Again, this is Kubernetes typical stuff, meaning that this is the one active. And right now, and I'm going to elaborate on it later, no schema for that CRD, just the CRD itself, right? Called SQL claim. If I apply this, let's apply it. You will see kubectl get composite resource definitions. You see SQLs with specific API, in this case, devopstoolkitseries.com, created. And similarly, if I do get CRDs and grep, let's say, DevOps, you will see that two CRDs, standard Kubernetes CRDs were created, SQL claims and SQL. One, this is namespaced, this one is cluster level. Now the good thing, and I'm not going through it in a book, but one of the big things, typically people start thinking of those things when they create internal platforms, right? Developer platforms, whatever people call it. And that means that I just extended Kubernetes API with new definitions. And that means that everything is discoverable, right? You could have a UI that would go to your Kubernetes cluster and say, give me the schema of that something so that I can paint the fields on a screen or whatever you do with it, right? I can do the typical kubectl explain SQL claims recursive, and then you get the schema in Kubernetes. It's a Kubernetes resource like any other. That's the important part. Now, if I would like to create an instance of SQLs, I could do it something like this, right? I can create now custom resource called SQL and called my DB, and there is no spec because I did not specify any schema for that CRD yet. And I can simply apply it. I can say this, right? Apply that, and I get kubectl get SQLs. I get one in my cluster, right? Now, that's not synchronized, not ready. Nothing is happening because so far I created just a CRD, custom resource definition, and I can create CRs, custom resources, but there is no controller. There is nothing in my cluster that is monitoring the events for that resource kind and doing anything, right? Just custom resource that does literally nothing, right? It would be like having ingress with creating ingress without installing an ingress controller first. That's the equivalent, right? And the reason why nothing is happening is because I did not create compositions. If you see compositions, there are none, right? So compositions will be Kubernetes controllers that will react on creating, updating, or deleting custom resources associated with that kind and API, right?
I thought you always needed the compositions. Interesting.
No, exactly. This is just, so this is the same as if I created ingress resource without installing ingress controller. Yeah. There is no, and Kubernetes, and this is a thing that what many people kind of misunderstand. Kubernetes doesn't care about you creating custom resources. It just stores the information in the database in etcd and says you created ingress. Whether there is a controller that will do something with it or no, not my problem, right? Same thing here so far. Now I have this, and this is me creating a controller, right? And those controllers, we call them compositions, and it has labels, meaning that I can have different compositions, and depending on labels, people can select to create one or the other, right? And in this case, I'm saying, hey, this composition should be associated with custom resources called SQL, as long as they have provider label AWS and database label Postgres, right? You can set that this is the default, so people don't have to specify labels. This is important. Labels are important only if you want to have different implementations of something.
And these labels are like, it could be foobar, Carlos and Viktor, true, equal, like you, this is your own conventions that how you want to match, how you want those APIs to find this implementation, right? So when you create the claim, you're looking for a composition of multiple compositions that implement the API.
Exactly.
Some people think these are like hard-coded because they see it in examples, but this could be like your own convention of like, I usually use here like prod versus dev or staging or test.
That's actually a good comment because I got that question and only now I realized that I should have called it something silly like Gandalf and Unicorn. So that nobody gets confused whether that's baked in or no, right?
It's not easy to get like understand this day one, right? So you have to gladly now we have a book. We didn't have a book.
The important part here is that I'm specifying that this implementation, this controller, is associated with custom resource definition called SQL, the one that I created before, right? Those things are decoupled. I'm coupling them now. And I have a resources section. Basically, this is me saying, hey, whenever somebody creates a SQL resource with those labels, you should create a VPC, and you should create one subnet, a second subnet, third subnet, subnet group, gateway, route table, etc., 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 right? You should create and manage all those resources. And those resources have, so far, everything is hard-coded. I will show you later how to not hard code things. But so far, because I did not specify the schema of my custom resource definition, so users have no control over anything except I want the database. I'll change that later.
But Victor, this is a good point to maybe teach or show people, like the one time that you want to put hard coded, and I suggest to put hard coded, will be when you're a platform team and this becomes your standard, that every VPC will have DNS support equals true, and I don't want to give the end user a chance to change it, right? This becomes your standard if they're hard coded, but if they're not, then provide defaults or inputs in the API, where in the first section that you show.
You know, that's kind of, I use Amazon very often as example, right? You're designing an interface for your customers, which in this case would be, let's say, developers, right? And let's say that would be Amazon. They decided that, hey, you should control whether you want 1 day shipping or 3 days shipping, because that matters to users. But then you don't specify should it be shipped by boat or a train. That's not their concern. And the same thing here, right? Like in this example, I would probably allow people to specify the region, but there is no good reason why they should specify, let's say, enable DNS hostname. It's always true, right? You hide the things that don't matter to people and expose things that do. I'm not doing it right now, but I will later. So everything hard-coded, just a list of resources, nothing more. And there is one important thing here, apart from hard-coded. Like in this example, I'm saying, hey, this subnet should use VPC that has this label. This is not the best way to do it. There are better ways, but I'm gradually kind of like building towards it. So far, what matters is that VPC is somewhere, and that VPC will have this label Crossplane IO composite set to MyDB. That's a label that is auto-generated by Crossplane whenever somebody will create an instance called MyDB. And then the rest is just a bunch of resources, right? I can go if you want through each of them, but I don't think that there is a reason. Just a lot of parameters set.
It's an array. It's an array of resources, so you can have 20, or you can have 5, or you can have 2, or you can have 1.
And the good thing also is that I'm not doing it here. I do it later, but you can combine different types of resources. So, for example, later on, I'm creating RDS in AWS with VPC subnets, whatsoever, but I'm also creating using SQL provider that will create a database in that server, in the database server, and some other provider or some other type of resource for schemas and so on and so. So you can combine a bunch of different sources to accomplish whatever you want to accomplish. I see questions here. I don't know whether I did not read them.
Yeah, I can read from the last bit if you want. So there was one conversation around like running Crossplane centrally or instance for each cluster. Maybe you can talk about trade-offs a little bit. Then go ahead.
I wouldn't run. So I definitely wouldn't run one Crossplane for each cluster that it manages, because that would be an overkill, right? Usually people have one or more Crossplanes depending on the scale and depending on the separation, right? You would have, like I've seen big companies running like multiple Crossplanes, depending on the team, right? And say, hey, this team should always have manage this thing, this Crossplane with those 1,000 resources, and some other team should. Usually people separate it either based on performance or scale or the internal organization within the teams.
Right. One from Joshua. I hope I got it right. The reason the controllers do not exist when you install the specific provider is because the controllers are for your specific composition, i.e. you can't provide a controller that would work for my composition because you don't know what it is before I write the manifest.
Yeah, so the whole, so there are two types of controllers. Let's say controller for EC2. That's a controller that was installed when I installed the EC2 provider, right? That comes out of the box when you install a provider. And the rest of controllers are you're designing them, right? I'm designing right now here in this example a controller that will create security group rule and what's or not whenever somebody creates SQL.
But Victor, there's no, it's a controller, but there's no new pod or like container running per composition. Or
Not per composition. Yes, there is one controller for a group of compositions, let's say. Because I can have the same composition with the labels Azure and Postgres, so there will be one controller for SQL. Let's put it that way.
What I'm trying to ask is, if you do kubectl get pods in the Crossplane namespace, you will see a new pod that got created because you created this composition?
Let's try it out. Let me, what did I want to do? Let me, So actually, before I try it out, just to be clear, I'm not going to show the source code, but if I go to the directory here, v1, what I showed before was AWS, but in that same directory, I have the same composition, not the same composition, but SQL, variation of SQL composition for Azure and Google, right? So I have 3 compositions here.
For the same API.
Yes, all the same, different labels only in resources, right? But they're all for SQL. And if I apply all that, here we go. Oh my!
You might not have the CRDs for the other.
Yeah, I think that my setup script was not as good as I'd hoped. Let me see. Okay, live debugging here.
But you created one composition, right? We can take a look at the one composition.
Yeah, but I did not install the providers. I just realized. And that's shame on me.
The script doesn't do it?
It's supposed to be doing it. It's supposed to be doing it, and I don't know why. Let's see. No, that's yeah, it's supposed to install. Let me see. This is configuration, fetch ANSI, create namespace, install Crossplane. This is Google stuff. This is no, here is. Let me see. What did I? Sometimes I forget what I wrote. Maybe it was not supposed to do that.
Yeah, it is. It is explicit. You have to do it.
Huh? Yeah, exactly. Sorry, I forgot what I wrote. That's how old I am. It's been happening more than 2 weeks ago. I don't remember it. So, if I apply this composition, it discovers that you're trying to do that. Cool. But that composition cannot find the provider for EC2 and what's not, right?
Okay, warning.
Warning, exactly. And to make it work, now there are 2 ways to make it work. The one that I'm showing you now is the one I showed before. You should not do this, but I'm going to show it anyway. I'm going to install provider for EC2, for RDS, and then for Google SQL and for Azure SQL, DB for Postgres, right? And if I apply it, now it should work. And if later on, I will show you how you can specify that in a better way. But if I output the packages, you will see that they're already active. So it's fine. Now I should be able to, I think that they're active. Yeah, let me check. Yes, cool. And the second thing I need to do is provide configuration so that it knows how to talk to my AWS account. That's the same thing as from previous chapter. Cool, I'm going to just apply it. This is my secret basically to AWS. And now, but here's the thing, right? I do not need to reapply the compositions because that was a warning. It's all about eventual consistency, right? Warning. It couldn't do much, but eventually it will, right? Once all the stars aligns, and if I output compositions, you can see that I have AWS PostgreSQL, Azure PostgreSQL, Google PostgreSQL. And there was your question. Let's check kubectl namespace crossplane system get pods and where is it? No, it doesn't create a
Yeah,
pod.
so the answer,
thought
I
it
already knew
create-
the answer. So there's no compositions controllers. Like when you say there's a composition controller, it's in the first one. It's in the Crossplane controller.
Crossplane
There's-
itself is
There's
managing. I
controllers
never checked it
inside of
myself.
Yeah, the controller, that's why it's so efficient. Imagine yourself creating so many pods and containers for every composition. It's not very efficient. So one of the good things of Crossplane is that that small controller is the logic for your compositions, because it's creating the resources, and then the other ones are doing the heavy work of talking to the cloud APIs.
Yeah, I never checked
Thank
it
you.
myself. There we go. Now, what you will see later is that you can use functions, and then you would have additional pods for your functions. But that would be one for, let's say, if you use Google Go templating, you would have one pod for all the compositions that might use that function. But that comes later. Where was I? So I created a definition, and I created 3 compositions, 3 implementations of that CRD. And now if I will create a Google secret. I forgot to mention, but at one point that composition was referencing Google secret, Kubernetes secret for the root password for RDS. This Kubernetes standard stuff. But what does matter here is that I'm saying, okay, I want to create SQL. I will call it MyDB, and the labels are going to be provider AWS DB Postgres, meaning that I'm going to choose one of those 3 implementations, and in this case, AWS. And
So these
if
are
I
the labels that we were talking earlier that were at the top of the composition. Like you're labeling the composition to then the claim will be able to find it by using normal Kubernetes. This is how Kubernetes works. It's based on match selectors based on labels.
I think that similar would be, imagine that I'm creating ingress.
Yep.
And I could have 5 ingress controllers. I could have traffic and Nginx, and then you have ingress class in the ingress resource that would select one of those.
Yep.
So if I apply that, I created my DB password, and I updated because the instance of that composition was already there from the very beginning. And now if I can use, and this is going back to the question earlier, one of the ways you can see what's going on is by executing Crossplane. This is a beta feature still. You can trace, in this case, SQL called MyDB, and that gives the tree of all the resources. And I just realized that I probably missed the part when I created the configuration, or mixed something up unchanged. What's wrong? Let me see. Describe SQLs. No compatible compositions found. I think that it is still did not enter into the next reconciliation group. It is still using the composite resource that I created at the very beginning when I did not have even the composition itself.
Yeah. 7 minutes.
I'm guessing. Probably the next reconciliation, when it comes here to 6, it will probably work. Okay, or we can do this. Delete SQLs MyDB, and then if I apply it again, this will no, not that one. Where was it? Here. Now if I do the better trace, there we go. You can see that those are all the resources that were created by that composition, right? Those, I don't know, 5, 6, 7 lines of YAML created the composite resource, and that resource creates managed resources depending on the specification that I said in composition, right?
Yeah,
there's
I
a bunch of
we can stop here, Victor, because I think the RDS database takes like 10 minutes or a few minutes to create.
Exactly.
And want to be, cautious with your time. So if you're going to join us next Friday to continue?
Yeah, Yeah,
Okay.
of course.
As long as you're having fun, I'll gladly have you here. So thank you so much for spending this time. And this is also content that's going to be in YouTube, right? For a lot of people to learn the in and outs of Crossplane.
Hey, it's not going to be on YouTube. I have a video for each chapter as well already. So.
Oh yeah, cool. Okay, you already have it in YouTube.
Yeah. It's all there.
Okay, even better.
But we have the juicy discussions here. So
yeah, the extra discussions. You can find it here.
Exactly.
Okay. Well, thank you so much, everyone, for joining. Next Friday we'll be here. I think Sebi will be here. Sebi.
Next week I'm taking my kid to a concert. I'm off, unfortunately.
Okay.
Yeah.
I'm traveling. I think I'm traveling, but we'll look for a host to help Viktor and.
Okay, let's try to
this.
figure it out. Okay.
Maybe Patil or somebody else wants to volunteer to help us here next week, and or Eric. But we'll figure that out. So until next time, thank you so much. I hope this was very useful for everyone. There was a lot of things, discussions in the chat, and a lot of good questions.
Carlos, I'm going to blame you for what I'm going to say, not myself, because I did not attend previous sessions, so I have no idea how long it will take. You said 3 sessions, it's not going to happen.
Yeah, we discussed this it's up to you. It's your time. I didn't want to take a lot of your time.
No, my time is when I enjoy something, time is never a problem, and I enjoyed this.
Okay, because you had another live stream. I think it was conflicting. So
yeah, no worries.
Okay, so if we continue next week, we continue on this until we finish the book. I mean, people are having fun. I'm having fun. I'm learning a lot. Like I didn't know a few things. Like actually, yeah. So until next week, Viktor will be here. So see you, everyone. Have a good weekend, everyone. See you.
Cheers, everyone.
Thanks.
Cheers, everyone. Thanks for joining.